Good afternoon, students. My name is Dilip Kumar, lecturer in physics. Today I am going to explain the chapter Alternating Current, AC. So, what is meant by alternating current? An alternating current or alternating voltage is one which varies periodically. Magnitude of the current and direction of the current, both magnitude and direction of the current varies with respect to time or varies periodically. Alternating current or alternating voltage time ಜೊತೆ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ವೇರಿ ಆಗುತ್ತೆ. ಏನು ವೇರಿ ಆಗುತ್ತೆ? ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಅಂಡ್ ಡೈರೆಕ್ಷನ್ ಕಂಟಿನ್ಯೂಸ್ಲಿ ಟೈಮ್ ಜೊತೆ ವೇರಿ ಆಗುತ್ತೆ, ವಿಚ್ ಇಸ್ ನೋನ್ ಆಸ್ ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್. So this is positive half cycle of AC. This is negative half cycle of AC. Alternating current or alternating voltage varies with respect to time. Okay. So next move on to instantaneous value of AC. Instantaneous value of AC. So what is meant by instantaneous value of AC? It is the value of alternating current or alternating voltage at any instant of time. The value of alternating current or alternating voltage at any instant of time is known as instantaneous value of AC current or alternating voltage. Instantaneous value of current is I is equal to I naught sin omega t, or I is equal to I naught sin of omega t plus phi. Instantaneous value of voltage or alternating voltage V is equal to V naught sin omega t, or V is equal to V naught sin of omega t plus phi. Omega t plus phi, which is called phase. Instantaneous value of alternating current I is equal to I naught sin omega t. Instantaneous value of alternating voltage V is equal to V naught sin omega t. What is I naught? I naught is peak current. I naught, this is I naught. I naught is peak current, or V naught. V naught is peak voltage. This is peak voltage. Alternating current or voltage time ಜೊತೆ continuous ಆಗಿ change ಆಗುತ್ತೆ. Okay. This is one cycle of AC. For one cycle of AC, time t is equal to capital T. So this time is t by 4. This is t by 2. This is 3t by 4. Okay. Small t is equal to capital T. Okay. Small t is equal to capital T. This is called as one cycle of AC. One cycle of AC. Okay. I is equal to I naught sin omega t and V is equal to V naught sin of omega t. Positive half cycle of AC. This is negative half cycle of AC. So next move on to average value of AC. Average or mean value of AC. The average or mean value of AC over one complete cycle is 0. One complete cycle ali average value of alternating current or average value of alternating voltage is 0. One complete cycle ತಗೊಂಡ್ರೆ alternating voltage ಅಥವಾ alternating current average value of alternating current is 0. Okay. So integration I mean is equal to integration from 0 to t. One wave means time t is equal to capital T. Integration from 0 to t I into dt divided by integration from 0 to t into dt. What is I? I is equal to I naught sin omega t. Mean or average value of current over one complete cycle is 0. Over one complete cycle, average value of alternating current is 0. Alternating voltage is also 0. Okay, which is equal to 0. If substitute I is equal to I naught sin omega t and apply integration, you will get to 0. So average value of AC one complete cycle 0 ಆಗುತ್ತೆ. So average value of current or voltage half cycle ಗೆ ಮಾತ್ರ ಡಿಫೈನ್ ಮಾಡ್ಬೇಕು ನಾವು. half cycle ಗೆ half cycle. So for half cycle I mean is equal to integration from 0 to t by 2. Integration from 0 to t by 2. Next page you go na. I average is equal to integration from 0 to t by 2 I into dt divided by integration from 0 to t by 2 I into dt. What is I? I is equal to I naught sine omega t. Okay. Average value of alternating current half cycle for half cycle is I naught I mean or I average is equal to 2 by pi into I naught. So I average or I mean is equal to 2 by pi into I naught. Similarly, V mean, okay, or V average is equal to 2 by pi into V naught. Okay, average value of alternating current or alternating voltage IM is equal to 2 by pi into I naught. Similarly, VM is equal to 2 by pi into V naught. So next move on to RMS value. RMS value of AC. So root mean square value of AC. RMS means root mean square value of alternating current or alternating voltage. So it is defined as square root of the mean of the squares of all the instantaneous values of AC over one complete cycle is nothing but VRMS or IRMS. IRMS is equal to I naught by root 2. RMS value of alternating current. RMS value of alternating voltage, VRMS is equal to V naught by root 2. I naught is peak current and V naught is peak voltage. This implies peak current I naught is equal to root 2 into IRMS. So V naught is equal to root 2 into VRMS. If so, for example, alternating voltage is 100 volts. Alternating voltage or AC volts is 100, which means VRMS is 100 volts. VRMS is 100 volts or V naught. V naught is equal to root 2 into VRMS. VRMS is 100. 100 volts means this is RMS value of voltage. RMS value of voltage, VRMS is equal to 100 into volts or V naught is equal to root 2 into 100. Yes. Next move on to power. Power in AC circuits. You know that product of voltage and current is called power. But in AC circuit or AC chapter, average power is equal to VRMS into IRMS cos phi. What is cos phi? Cos phi is called power factor. Cos phi is power factor. Average power in AC circuit, average power or true power in AC circuit, V average is equal to VRMS is equal to V naught by root 2. IRMS is I naught by root 2 into cos phi. So P average is equal to V naught I naught divided by root 2 into root 2, 2 into cos phi. Very important formula. Average power or true power in AC circuit. Okay. Next move on to circuits. Circuit number 1, AC through a resistor. AC through a resistor. Alternating voltage is applied to a resistor. Consider a resistor of resistance R which is connected across AC source. AC source. Instantaneous value of alternating voltage is V is equal to V naught sine omega t. V is equal to V naught sine omega t. When alternating voltage is applied to a pure resistor of resistance R, V is equal to V naught sine omega t is instantaneous value of alternating voltage, and instantaneous value of alternating current is I is equal to I naught sine omega t. I is equal to I naught sine omega t. What is I naught? I naught is peak current. I naught is equal to V naught divided by R. Peak current in the circuit I naught is equal to V naught by R. So V is equal to V naught sine omega t and I is equal to I naught sine omega t. Here phase difference between voltage and current in resistive circuit is 0. Phase difference is 0. Pi is equal to 0 degree. If phase difference is 0, both current and voltage are in phase with each other. Voltage and current are in phase with each other because phase difference is 0. Phasor diagram. Voltage and current both are in phase with each other when alternating voltage is applied to a resistor. VRI, okay, versus time. Both voltage and current are in phase with each other. This is alternating voltage V. This is alternating current. Okay, rest circuit ಅಲ್ಲಿ ಎರಡು ಕೂಡ ಏನಾಗಿದೆ in phase ಅಲ್ಲಿ ಇದೆ. Voltage across the resistor VR, which is in phase with the current. Phasor diagram or phase diagram, or you can also write it as voltage and current in phase with each other. Voltage and current in phase with each other. Okay. Peak current is I naught is equal to V naught by R. Phase difference is 0. Okay. Here voltage and current both are in phase with each other. Phase difference is 0. So what is the power? Power or average power or true power in this circuit. What is true power? P average is equal to what? P average is equal to V naught by root 2 or V naught I naught by 2 into cos phi. Phase difference is 0. If phase difference is 0, cos 0 degree is equal to 1. Average power or true power P average is equal to V naught into I naught divided by 2 or VRMS into IRMS. Therefore, power consumed is maximum in a resistive circuit. Second circuit is circuit number 2, AC through an inductor. Circuit number 2, alternating voltage is applied to an inductor. Inductor of inductance L. Inductor of inductance L, which is connected across alternating source. An inductor of inductance L, which is connected across AC source. Instantaneous value of alternating voltage V is equal to V naught sine omega t. V is equal to V naught sine omega t. Correct as equation number 1. And instantaneous value of alternating current, an inductor of inductance L, which is connected across alternating source, is I is equal to I naught sine of omega t minus pi by 2. From equations 1 and 2, what is the phase difference between voltage and current? Pi by 2. Phase difference is pi by 2. Phase difference is pi by 2 or voltage leads the current by an angle of pi by 2. When alternating voltage is applied to inductor, alternating voltage leads the current by an angle of pi by 2. Or phase difference between current and voltage is pi by 2 in inductive circuit. Now, what is the phase diagram? Phase diagram or phasor diagram. This is voltage. Voltage leads the current by an angle of pi by 2. This is current. Alternating current lags behind the voltage, or voltage leads the current by an angle of pi by 2 in inductive circuit. Or voltage across the inductor leads the current by an angle of pi by 2. Or voltage leads the current by an angle of pi by 2. So what is I naught? I naught is peak current. Peak current I naught is equal to V naught divided by XL. What is XL? XL is nothing but inductive reactance. Opposition offered by the inductor to the flow of AC through it is called inductive reactance. XL is equal to inductive reactance. Inductive reactance. XL is equal to inductive reactance or opposition offered by the inductor. XL is equal to V naught by I naught. What is XL? XL is equal to omega into L. What is omega? Angular frequency 2 pi f into L. XL, inductive reactance XL is equal to omega into L. But what is omega? Omega is 2 pi f into L. XL, which is proportional to f. What is f? Frequency of alternating source. Frequency of alternating source. In India, frequency of AC is 50 Hz. And voltage is RMS voltage. VRMS is 220 volts. XL is proportional to F and XL is proportional to L. What is L? L is self-inductance. If the value of self-inductance increases, opposition offered by the inductor increases. If frequency of AC source increases, then opposition offered by the inductor also increases. Okay. XL, inductive reactance in terms of VRMS and IRMS, RMS value of voltage and RMS value of current. Okay. XL is equal to V naught divided by I naught. We know that V naught is equal to VRMS into root 2. Root 2 gets cancelled. Okay. VRMS divided by and I naught is equal to root 2 into IRMS. Okay. So XL is equal to omega into L. Omega is 2 pi f into L. In this circuit, our alternating voltage is applied to pure inductor or inductor. Voltage leads the current by an angle of pi by 2. Phase difference between current and voltage is pi by 2, or current lags behind the voltage. Current lags behind the voltage by an angle of pi by 2. So move on to next page. XL is directly proportional to F, and also XL directly proportional to inductor of self-inductance L. Okay. Now, power consumed or average power. Average power in this circuit, average power, true power, what is the formula? P average is equal to VRMS into IRMS cos phi. What is the phase difference between current and voltage in this circuit? 90 degree. Cos 90, 0. Average power or true power is 0. No power consumed in inductive circuit. Power consumed is 0. Power consumed power consumed is 0 when alternating voltage is applied to inductor or pure inductor. Okay, this is about inductive circuit. Circuit number 3, AC through a capacitor. Alternating voltage is applied to a capacitor. Capacitor is a device which is used to store electric charges or electric energy in the form of electric field. Consider a capacitor of capacitance C which is connected across alternating source or AC source. Alternating source or AC source. Instantaneous value of alternating voltage is V is equal to V naught sin omega t. V is equal to V naught sin omega t. And instantaneous value of alternating current in this circuit, I is equal to I naught sin of omega t plus pi by 2. Pi by 2 is the phase difference. Phase difference between current and voltage in capacitive circuit is 90 degree or pi by 2. Okay. So here current leads the voltage. Current leads the voltage by an angle of pi by 2 or 90 degree. When alternating voltage is applied to a capacitor, voltage lags behind the current or current leads the voltage by an angle of pi by 2. Phase difference between current and voltage is pi by 2. What is I naught? I naught is peak current. Peak current in this circuit, I naught is equal to V naught divided by XC. What is XC? XC is called capacitive reactance. Opposition offered by the capacitor to the flow of AC through it is called capacitive reactance. Capacitive reactance XC is equal to V naught by I naught. What is XC? XC is equal to 1 by omega into C. Inductive reactance is XL. Capacitive reactance is XC. A portion offered by the inductor is called XL. A portion offered by the capacitor is XC. What is omega? Omega is 2 pi into F. XC is equal to 1 by 2 pi F into C. XC depends inversely on frequency of the alternating source, and also XC depends inversely on capacitance of the capacitor. When frequency of alternating source increases, capacitive reactance decreases. And also capacitance of a capacitor increases, capacitive reactance decreases. Why? Because capacitive reactance Xc depends inversely on both frequency of alternating source and capacitance of the capacitor. So next move on to phasor diagram or phase diagram. Phase diagram or phasor. Current leads the voltage by an angle of pi by 2. In a capacitive circuit, current leads the voltage across the capacitor by an angle of pi by 2. Current voltage na pi by 2 angle leading ಮಾಡ್ತಾ ಇದೆ or Voltage across the capacitor Vc lags behind the current by an angle of pi by 2. Or phase diagram can also be written as voltage, current leading the voltage by an angle of pi by 2. Pi by 2, which is the phase relationship between our phasor diagram, okay, between current and voltage. So next one. This is voltage, alternating voltage. In capacitive circuit, current leads the voltage by an angle of pi by 2. Current leads the voltage by an angle of pi by 2. V is equal to V naught sine omega t, instantaneous value of alternating voltage. Instantaneous value of alternating current I is equal to I naught sine of omega t plus pi by 2. So this is alternating voltage applied to a capacitor or pure capacitor of capacitance C. So moving on to next circuit, series circuit number 4, series LR or RL circuit. Series LR circuit or RL circuit or AC through a series LR or RL circuit. RL circuit. So here the resistor of resistance R and inductor of inductance L connected in series. R and L both are connected in series through or across AC source. A resistor of resistance R and inductor of self-inductance L or inductor of inductance L both are connected. R and L are connected in series with alternating source. Let I be the RMS value of current in the circuit. Voltage, this circuit is series circuit. In series, current is constant. Applied voltage is divided. Applied voltage means RMS value of voltage. RMS value of voltage across inductor and okay, resistor divide ಆಗ್ತದೆ. Voltage across resistor is VR. Voltage across the resistor is VR. Voltage across the inductor is VL. VR and VL. What is VR? VR is voltage across the inductor. VR is equal to I into R. It's potential difference or voltage across the resistor. Sorry, voltage across the resistor is VR. VR is equal to I into R. Voltage across the inductor is I into XL. What is XL? Inductive reactance. Potential difference across resistor is VR. VR is equal to I into R as per Ohm's law. Potential difference or voltage across inductor VL is equal to I into XL. XL is inductive reactance. So write phase diagram. In inductor, we know that voltage across the inductor VL leads the current by an angle of pi by 2. ಇಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, ವೋಲ್ಟೇಜ್ ಕರೆಂಟ್ ನ ಲೀಡ್ ಮಾಡ್ತಾ ಇದೆ. ಇನ್ ರೆಜಿಸ್ಟರ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್? ಇನ್ ರೆಜಿಸ್ಟರ್, ವೋಲ್ಟೇಜ್ ಅಕ್ರಾಸ್ ದ ರೆಜಿಸ್ಟರ್ which is in phase with the current. In resistor, phase difference between voltage and current is 0. In inductor, phase difference between current and voltage is pi by 2. So what is instantaneous value of alternating voltage? V is equal to V naught sin omega t. V is equal to V naught sin omega t. Okay. To find the resultant voltage of VR and VL, okay, we need to draw phasor diagram or phase diagram. In resistor, what happens? In resistor, voltage across the resistor which is in phase with the current. In inductor, what happens? In inductor, voltage across the inductor leads the current by an angle of pi by 2. Phase difference between voltage and current is 90 degree, where in inductor. Okay. Now resultant of VL and VR, the resultant voltage of VL and VR is V, which is represented by OC. OA, which represents VR, OB, which represents VL. OC is equal to V, OA is equal to VR, OB is equal to VL. What is V? V is resultant voltage of VR and VL, where in RL circuit or LR circuit. Okay. Now what is the resultant voltage? Resultant voltage. Now from the triangle, OC square is equal to OA square plus OB square, or OC is equal to square root of OA square plus OB square. OC is equal to resultant voltage. What is OA? VR, VR square plus what is OB? OB represents VL, VL square. What is VR? VR is I into R, I square, R square. Plus what is VL? VL is I into XL, I square, XL square. V is equal to I into square root of R square plus XL square, or V by I is equal to square root of R square plus XL square. What is V by I? V by I is equal to Z. What is Z? Impedance of the series LR circuit. What is impedance? Effective opposition offered by the resistor and inductor to the flow of AC through it, which is called as impedance. Z is nothing but impedance. Impedance of the circuit, Z is equal to square root of R square plus XL square. Impedance of the circuit, Z is equal to root of R square plus XL square. What is impedance? Effective opposition offered by the series LR circuit or RL circuit to the flow of AC is called impedance. Now current in a circuit. Current in the circuit. Okay, next slide ಹೋಗೋಣ. Current in the circuit I is equal to V by Z. What is Z? Root of R square plus XL square. Z is equal to impedance of the circuit. Z is equal to root of R square plus XL square. What is XL? XL is omega into L whole square. Z is equal to root of R square plus what is omega? 2 pi F into L whole square. Z is equal to square root of R square plus 4 pi square F square L square. Impedance of circuit Z is equal to root of R square plus 4 pi square F square L square. Impedance of LR or RL circuit is directly proportional to frequency of the alternating source. As the frequency of alternating source increases, impedance of the circuit also increases. Impedance frequency ಮೇಲೆ okay directly depend ಆಗುತ್ತೆ. Frequency increase ಆದರೆ impedance increase ಆಗುತ್ತೆ. As frequency decreases, impedance of the circuit also decreases. Okay. Now we need to find out phase difference or phase angle between current and voltage. Phase angle or phase difference. Phase difference between resultant voltage and current in the circuit. Let pi, what is pi? Angle made by the resultant voltage with x-axis or current axis. Okay, this is VR, this is VL. From this triangle, tan phi is equal to what? Tan theta or tan phi is equal to opposite side. Opposite side is nothing but VL divided by adjacent side. Adjacent side is VR. What is phi? Phi is the phase angle or phase difference between resultant voltage and current in series RL circuit. Tan phi is equal to VL by VR. What is VL? I into XL. What is VR? I into R. I gets cancelled. Tan phi is equal to XL by R. What is XL? Omega into L divided by R. R. Phi is equal to phase difference between resultant voltage. What is V? V is resultant voltage of VR and VL. So phi is equal to tan inverse of XL by R. Or phi is equal to tan inverse of omega L divided by R. What is phi? Phi is phase difference between the resultant voltage and current in RL circuit. So in this circuit, voltage leads the current by an angle of phi. Pi is the phase difference between voltage and pi ಎಷ್ಟಿರುತ್ತೆ ಗೊತ್ತಿಲ್ಲ ನಮಗೆ. Okay, pi is the phase difference between voltage and current. Here voltage applied alternating voltage is V is equal to V naught sin omega t, and current in the circuit I is equal to I naught sin of omega t minus phi. Sin of omega t minus phi, because in resistor voltage and current both are in phase with each other. But in inductor, voltage leads the current by an angle of pi by 2. But in case of RL circuit or LR circuit, Phi is the phase difference between resultant voltage and current. So current lags behind the voltage by an angle of phi, or voltage leads the current by an angle of phi. Okay, this is about RL circuit or LR circuit. So next circuit is circuit number 5, AC through a series RC circuit. RC circuit. In this circuit, resistor of resistance R and capacitor of capacitance C both are connected in series with alternating source or AC source. A resistor of resistance R and capacitor of capacitance C connected in series through or across alternating source. Let I be the RMS value of current in the circuit. Instantaneous value of alternating voltage is V is equal to V naught sine omega t. Here R and C are in series. In series, voltage is divided, but current is constant. Voltage across R or resistor is VR. Voltage across capacitor is VC. Voltage across R, VR is equal to, as per Ohm's law, VR is equal to I into R. As per Ohm's law, VC is equal to I into XC. Potential difference across resistor is VR is equal to I into R. Potential difference across capacitor, VC is equal to I into C. We know that in resistor, voltage across the resistor which is in phase with the current. But in case of capacitor, we know that current leads the voltage across the capacitor by an angle of pi by 2. In resistor, voltage and current both are in phase with each other. Phase difference between them is 0 degree. But in capacitor, current leads the voltage by an angle of pi by 2, or voltage lags behind the current by an angle of pi by 2. Okay. Next, we have to find the resultant voltage. To find resultant voltage in RC circuit, we need to draw phasor diagram. Phasor diagram or phase diagram. In resistor, voltage across the resistor which is in phase with the current. In capacitor, voltage across the capacitor is lags behind the current, or current leads the voltage by an angle of pi by 2. OA represents VR, OB represents VC. The resultant voltage of VR and VC is V. V is net voltage or the resultant voltage. The resultant voltage is represented by OC, which gives direction and magnitude of the resultant voltage. Okay, from Pythagoras theorem, OC is equal to root of VR square plus VC square. OC is represents V. What is V? V is resultant voltage. V is equal to root of, what is VR? VR is nothing but I into R, I square R square, plus what is VC? VC is nothing but voltage across capacitor. VC is equal to I into XC, I square XC square, or V is equal to square root of I square into R square plus XC square, or V is equal to I into square root of R square plus XC square. V by I is equal to root of R square plus XC square. What is XC? A portion offered by the capacitor, which is called as capacitive reactance. What is V by I? V by I is equal to Z. What is Z? Impedance. Impedance of the series RC circuit or CR circuit. Impedance Z is equal to square root of R square plus XC square. Impedance of the circuit. But what is XC? We know that XC is equal to 1 by omega into C. What is omega? Frequency, angular frequency, 2 pi f into C. If we substitute the value of XC is equal to 1 by omega C is equal to 1 by 2 pi f into C in this equation, then Z becomes Z is equal to square root of R square plus 1 by omega C whole square, which is impedance of the circuit. Impedance Z is equal to square root of R square plus 1 by, what is omega? 1 by omega C whole square. Z is equal to square root of R square plus 1 by 2 pi f into C whole square. Z is equal to square root of R square plus 1 divided by 4 pi square f square C square. Impedance of series RC circuit is Z is equal to square root of R square plus 1 by 4 pi square f square into C square. Z depends inversely on frequency of the AC source or alternating source in case of RC circuit. Z depends inversely on frequency. As frequency of alternating source increases, impedance of the circuit decreases. Next, phase difference or phase angle between resultant voltage and current. Phase angle or phase difference. Phase difference between resultant voltage and current. What is V? V is resultant voltage of VR and VC. Phase difference between V and I. VR, VC, resultant voltage. Let pi be the angle made by the resultant voltage with x-axis or current axis. So from this triangle, tan phi is equal to VC. Tan phi is equal to VC divided by VR. Tan phi is equal to, what is VC? I into XC. What is VR? I into R. I gets cancelled. Tan phi is equal to XC by R. Or tan phi is equal to, what is XC? 1 by omega C into R. Or phi is equal to tan inverse of 1 by omega into CR. What is phi? Phi is phase difference between resultant voltage and current in RC circuit. Phi is equal to tan inverse of 1 by omega into CR. What is omega? Omega is 2 pi into F. Applied alternating voltage is V is equal to V naught sin omega t. But in this circuit, current leads the voltage by an angle of pi. I is equal to I naught sin of omega t plus phi. current leads the voltage by an angle of pi, or voltage lags behind the angle phi, where phi is angle, voltage lags behind the current by an angle of pi. What is phi? Phi is phase difference between resultant voltage and current. Okay. So this is about RC circuit. Next one is okay. Next one is circuit number 6, LC circuit. Or series LC circuit. Alternating voltage is applied to series LC circuit. What is L? L is inductor of inductance L. What is C? Capacitor of capacitance C. Both are connected in series with alternating source or AC source. Inductor of inductance L and capacitor of capacitance C are connected in series with alternating source. Let I be the RMS value of current in the circuit. V is equal to V naught sin omega t. What is V is equal to V naught sin omega t? Instantaneous value of alternating voltage V is equal to V naught sin omega t. Voltage across inductor is VL. Voltage across the capacitor is VC. In series circuit, current remains constant, but applied voltage is divided. Voltage across inductor is VL and voltage across capacitor is VC. What is VL? Voltage across inductor, or potential difference across inductor. VL is equal to I into XL. Potential difference across capacitor. VC is equal to I into XC. We know that in inductor, voltage across the inductor VL leads the current by an angle of pi by 2. But in capacitor, current leads the voltage across the capacitor by an angle of pi by 2. Phase difference between current and voltage, impedance find out ಮಾಡಬೇಕಂದ್ರೆ first ನಾವು phasor diagram draw ಮಾಡಬೇಕು. Phasor diagram or phase diagram. In inductor, what happens? In inductor, voltage across the inductor VL leads the current by an angle of pi by 2. In capacitor, what happens? In capacitor, voltage across the capacitor lags behind the current, or current leads the voltage by an angle of pi by 2. VL is voltage across inductor, VC is voltage across capacitor. Phase difference between VL and I is pi by 2. Phase difference between VC and I also pi by 2. Now, the resultant of VL and VC is what? Resultant of VL and VC. The resultant of VL and VC is V. The resultant voltage of VL and VC is V. V is equal to VL difference VC. If VL greater than VC, if VL voltage across inductor greater than voltage at capacitor, if VL greater than VC, the resultant voltage in the circuit V is equal to VL minus VC. If voltage across capacitor in the circuit which is greater than voltage across the inductor, if VC greater than VL, the resultant voltage in the circuit V is equal to VC minus VL. What is VL? VL is nothing but voltage across inductor. VL is equal to I into XL and VC is equal to I into XC. What is impedance of the circuit? Impedance means effective opposition offered by series LC circuit or RL circuit. Impedance of the circuit is the resultant voltage V is equal to VL difference VC. VL is equal to I into XL. VC is equal to I into XC. V is equal to what is VL? I into XL. Difference I into XC. V is equal to I into XL difference XC, or V by I is equal to XL difference XC. V by I is equal to Z. Z is equal to XL difference XC. Impedance of the circuit. Z is equal to XL difference XC. If VL is greater than VC, if VL is greater than VC, voltage across inductor greater than capacitor. If VL greater than VC, then XL greater than XC. What is XL? XL is omega L. Omega L which is greater than XC. XC 1 by omega C. If VL greater than VC, obviously XL greater than XC. V means voltage, X means opposition offered by the inductor and capacitor. Then the resultant voltage V is equal to VL minus VC, and the resultant opposition is nothing but impedance of the circuit Z is equal to XL minus XC. If VC greater than VL, if voltage across capacitor is greater than inductor, if VC greater than VL, then XC greater than XL, or 1 by omega C greater than omega into L. If VC greater than VL, the resultant voltage is V is equal to VC minus VL, and the resultant opposition or impedance of the circuit Z is equal to XC minus XL. If VL is equal to VC, what happens? If VL is equal to VC, voltage across inductor is same as that of voltage across capacitor. If VL is equal to VC, XL is equal to XC. The resultant voltage is 0 in the circuit. The resultant opposition or impedance of the circuit is also 0. If VL is equal to VC, then XL is equal to XC. The resultant voltage is 0, impedance is also 0. Then what is phase difference between voltage and current? Phase difference between resultant voltage and current. We know that in inductor, voltage leads the current by an angle of pi by 2. In capacitor, voltage lags behind the current by an angle of pi by 2. Phase difference between voltage and current in both the cases is 90 degree or pi by 2. Okay. So, phase difference is 90 degree. So, what is the power in the circuit? We know that average power P average is equal to Vrms into Irms cos phi. Phi is 90, cos 90 is 0. Average power in the circuit LC or CL is 0. Okay. Very important point. No power consumed or power consumed is 0 in series LC circuit or CL circuit. Yes. Okay. Thank you. We'll continue in the tomorrow class.